What? Of course not. We are never done. Yeah. Looks like Ryan's done because he's on to English, man. He's on to better things there. Yeah, he's reading his book. Hang on, let me finish this and then you can ask me a question. So, what should this be? What happens to the 4 and the 2? Negative 2. Can I combine x and root x using exponents? Using exponents. What's root x as an exponent? 1/2. So then I get x times x to the 1/2. Now what happens? What do I get? Which is what? Right, exactly right. Negative 2x to the 3/2. Are you guys with me on this? Okay, this last step that I did is algebra 0, okay? It's algebra 0, things that you did down at Gomes. Or Mission, or wherever you guys went. Okay, is everybody all right on this? Now, let me just go back to the computer activity, right? In that activity, you came up with a very famous rule. Can someone tell me what that rule is? Yeah, tell me what it is. What's the power rule? So if you have your function xn, then its derivative is nice. Okay? So remember our function originally that we started out with, f of x, was equal to 4 over square root of x. Can I write this in terms of exponents? 4 to the x to the negative 1/2 because it's downstairs. Oh. And if you apply this rule to it, what is n equal to? What's n equal to? No, look at this and compare this. Compare this, my bad. Compare that. What's n equal to? Negative 1/2. Is everybody with me on that? So then what I get from here is I'm going to get a 4, which is my 4 that was standing outside here. My n is a negative 1/2. And then it's going to be x n minus 1. Negative 1/2 minus 1. Negative 3 over 2. Isn't that the same answer that we got through a very laborious process? Oh, but, okay, your great forefathers in the Neanderthal age, circa 1400, went through the agony. So you need to go through the agony as well, so you can appreciate them and pay them homage and kind of say, thank you guys for doing all this work for me. So we don't have to do this, we can go straight to this rule. But you did do it, except now you are doing it only for a little while. Come 2.2, we will formalize these rules and I'll bless you with those rules and you can use those forever and ever and you don't have to do the limit process.
Is that tomorrow?
That's tomorrow. Yeah. But the limit process pain may be on the test or will be on the test. Okay? Any other questions you want me to go over? Any other questions you want me to go over? So I highly recommend that you bust your books open, get started on your homework. If you need help, this is the time to get it because tomorrow I move on to 2.2. 49, okay? Same page, 104, right? 105. $49 is, in some ways, it's kind of tricky, okay? Okay, Hiba, to do 49, okay, people, shh. You got to be working or S up. And S up, not or, and S up. Okay, you want to really compare this to an alternative definition of the limit, okay, of the derivative. So this is like f prime of x, or f prime of c, okay, because you can see there's no x, there's a delta x, but there's no x. So this is a derivative at a point, okay. We had an alternative definition for that. Okay, do you know where that is? Yeah, where in the book? What page is it on? Nice, good job. You see it there at the bottom? Okay, so now if you compare this, to this, you can see that delta x is x minus c. Remember what your question is, okay? They're asking you, what do you think f of x is? Find f, find c. Okay? So you've got delta x is equal to x minus c if you make this comparison. Okay? And then what you do is you take this and you shove it in there. Okay? So then your upstairs becomes like limit 5 minus 3 into 1 plus x minus c minus 2 all over delta, all over x minus c. Okay. I'll tell you honestly that this is kind of a challenging problem. I gave it to my AP kids and they couldn't do it either. So don't fret too much about it. But at least I'm doing it for you so you get some understanding. And this is recorded, so if you want to view it again, you can view it. Yeah, it's not an easy problem. It's not an easy problem. Okay, so I'm not done yet. Okay, so if I look at this guy here, then I get, so this is 5 minus 3 minus 3 into x minus c. Actually, you know what? I'm just going to expand everything out, okay? Just expand everything out. So you get 5 minus 3 minus 3x plus 3c minus 2, okay? All over x minus c. And then I'm just going to focus on the upstairs, okay? So the upstairs becomes 5 minus 3 is 2, okay? And then this 2 cancels. And then this guy gives me negative 3x minus c, which is equal to, now I have f'd up somewhere here. I need to pause and think about this. You don't want to expand that stuff, okay? That's not really a nice thing to do. So what you want to do is, you can see, for example, if you compare this stuff that's in black here with this stuff here, what you want to do is you want to make this connection. This guy is going to be that. Okay, because this minus sign will match with that minus sign. Okay, which means that this guy here is only a function of x. In other words, you do not want c in it. You do not want c in it. See that? There's no c in there, is there? So you want to take c out of here. It's just a gut feel, right? Because this is fx, so you want a function of x minus some constant. So here's your constant. So then this whole thing is going to be your f of x. Okay? So if you don't want c in here, if you make c is equal to 1, then it'll cancel out with that. Are you with me on that? So then fx is equal to 5 minus 3x. Yeah, I mean, you're looking at patterns, basically. You're looking at two forms and you're comparing them. And then you got to kind of make sure that this makes sense, because if I tell you if c is equal to 1, then what's f of c equal to? If you look at this. C is equal to 1. So remember, when c is equal to 1, you mean x equals 1. Remember, c is x, right? Because x is going towards c. So if you put x equals 1, what do you get? 2, right? So here's your f of c, right? Isn't that what we started out with? That's f of c and there's f of c. So you can see it checks, makes sense. So c is equal to 1, f of x is equal to 5 minus 3x. Yeah, this is a challenging problem. It's really an AP question. Yeah, it's really an AP question. I mean, literally is an AP question. That's the kind of question you get on an AP. Okay, so am I done? Okay.